Okay, so now we're going to look at polynomial division, long division. Okay, so polynomial division. This is going to help us to factor polynomials that are in the standard form, the expanded form. It's going to help us to factor those, to put into factored form, so that we can then graph them. Okay, so polynomial division. First of all, we need to look at what long division looks like. Okay, so let's try something like, how about 247 divided by 4. So the way long division works is you look at to see how much 4 goes into 2, and if it doesn't go in, you move on to the next one. 4 goes into 24. So 4 goes into 24, well, 6 times. So 6 times 4 is 24. You're actually looking at how many times 4 goes into 240. Okay, so how many times 4 go into 240? It goes in 60 times. We're going to put a 6 here, and then we're going to worry about the 7 afterwards. So the way they work it is they do 24 minus 24, which is 0, okay, or 247 minus 240, and what you have left then is the 7. And then how many times does 4 go into 7? Well, it goes in once. 1 times 4 is 4. 7 subtract 4 is 3. So 4 goes into 247 61 times. Okay? 60 times for the 240 plus 1 time for the 7. And then you've got, you can write a little statement here now that 247 equals 4 times 61 plus the remainder, which is 3. Okay, so 4 times 61 is 244 plus 3 makes 247. Okay, another way of writing this is, if you want to write it as an actual division, you've done 247 over 4 equals 61 plus 3 over 4. So it goes in 61 3/4 times. Okay, so that's another way of looking at that division. We're going to use the same process now for dividing polynomials. So let's take a cubic and we'll divide it by this linear here. So this is mostly what we want to do. So x minus 3, and I'm going to do this long division sign here, and I'm going to put in x cubed minus x squared minus 11x plus 15, and I'm going to try and divide this by this so that I know what to multiply this x minus 3 by to get this. Okay, so first thing I want to do is I want to get rid of this x cubed, just like up here when I want to get rid of the 2 or the 24 when I subtract it. Okay, so what do I multiply x minus 3 by so I get an x cubed in it? Well, I'm going to use x squared. So x squared times x is x cubed. X squared times negative 3 is minus 3x squared. Now I'm going to subtract these polynomials. So what I did here was I just carried down the 7, but if I put a 0 in here and did 240, it would be 247 minus 240, which would give me 7. So I'm going to do it that way here. I'm going to do this whole polynomial minus this polynomial. So you're going to have to look at like terms. X cubed minus x cubed, 0x cubed. Negative x squared minus negative 3x squared. So when you're subtracting a negative, you're adding. So negative 3, or negative x squared minus negative 3x squared is going to be positive 2x squared. And then these, minus 0, is just going to stay the same. Okay. Now the next step I want to do is I want to get rid of this 2x squared. What do I have to multiply x by to get 2x squared? Plus 2x. Okay. So if I was just to multiply x minus 3 times x squared, I would get this. this is not quite the polynomial I want, so I got to keep working for more. Okay, so 2x now might get me closer. 2x times this is going to be 2x squared minus 6x. And now I'm going to subtract again. These will go away. Negative 11x minus negative 6x. Well, that's going to be plus 6x. So it's going to be negative 5x plus 15, because there's nothing to subtract from the 15 yet. Okay, now I'm getting close. Okay, so x minus 3 times this is getting me close. I just have this amount left. So I'm going to now multiply x times negative 5, negative 5x, and times negative 3 is going to give me plus 15. And look at that. I subtract that, I get 0 remainder, which means that x cubed plus 2x minus 5, sorry, I just wrote that wrong, x cubed minus x squared minus 11x plus 15 equals these two multiplied by each other. X minus 3 times x squared plus 2x minus 5. Okay, so I can write this division statement of this actual division here. And because there's no remainder, I can just put plus 0 here or just leave it. So when you think about factoring, this cubic is now partly factored. If you could factor this quadratic, which you know how to factor quadratics, you can completely factor this and then probably graph it as a function. Okay? So now the problem is to try and figure out how do you get this factor here. Well, in order to do that, you need this division to give you a remainder of 0. If something is a factor, well, when you divide it in, the remainder is 0. Okay, so let's take a look at some more division where we're not necessarily factoring, we're just practicing this division here. And you may not get a remainder of 0. So let's try this one here. X minus 2 divided into x to the 4th minus 16x cubed plus 4x squared plus 10x minus 11. And let's try to get rid of the x to the 4th here. So I'm going to multiply by x cubed. X cubed times x minus 2 is going to be x to the 4th minus 2x cubed. Subtract those. I'm going to get negative 14x cubed plus 4x squared plus 10x minus 11. Okay. And then I want to get rid of the negative 14x cubed, so I'm going to do times negative 14x squared times this. Negative 14x cubed. Negative 14x squared times negative 2 is going to be 20 plus 28x squared. Subtract those. So you can pause and keep trying this if you want. Now you're going to, these are going to disappear. 4 minus 28 is going to be negative 24x squared plus 10x minus 11. Now we need to multiply by negative 24x. Okay, here, negative 24x squared, negative 24 times negative 2 is plus 48. X, subtract, those go away. That's going to give me negative 38x minus 11. And then you're now going to multiply by negative 38. Okay, so negative 38x, and then negative 38 times negative 2 is plus 76. And subtract those, and you get negative 87 as the remainder. Okay, So because we got a remainder that's not 0, that means that x minus 2 is not a factor of this. Okay? So we could write out the division statement for this, which is this whole thing here times this, or equals this, times that, minus 87. Okay? And it would look something like this here. Okay. So that would be the division statement for that in two different ways. Okay? So now what about something that's a little bit more complicated? Maybe you're dividing by a non-linear term. So this is a linear term that we're dividing by. What if we're dividing by, say, a quadratic or a cubic? Okay, so let's try something. X squared minus 4 divided into x to the 4th minus 15 x cubed plus 2 x squared plus 12x minus 10. Okay, so you can pause and give that a try, and then I'll show you the answer. Okay, so this one, now you're looking to get rid of the x to the 4th term, so you're going to have to multiply by x squared. X squared times x squared is x to the 4th. X squared times negative 4 is negative 4x squared. We're looking for a cubed term here, but it's not there. So we're going to just put it down here. Minus 4x squared. Okay? So when you subtract, that goes to 0. You're still going to have a negative 15x cubed. And then 2 minus negative 4 is going to be plus 6x squared plus 12x minus 10. Okay. Now you're going to multiply by negative 15x. Get negative 15x cubed. And okay, so negative 15x cubed plus 60x. Subtract, you're going to get 6x squared. 12 minus 60 is negative 48. X minus 10. And then you've got plus 6 for this, so 6x squared, and then minus 24. Subtract, and you've got negative 48x plus 14. Okay, and this is the remainder. The remainder is not a constant anymore. The remainder is a polynomial. But the degree of this must be less than the divisor. Otherwise, it can go in more. Okay, so the division statement for this one, well, that looks like, where is it here? Right there. Okay, so you got two division statements for that one. Hopefully you can see that. All right, and here is another example that I'll just flash in here, and you can pause and look at it if you want. Okay, so right there is another one. All right, so that is long division of polynomials.